So what I want to do in this video is step through a problem that is almost identical to the problem that you're going to have to do in your homework, but with one important uh, change so that I'm not doing exactly your homework problem, which is that on your homework, these are all north poles, and I've changed this to be a south pole. So we're going to think about starting a loop of wire this way, and I want to have it rotate in a way that be designed in a way that will cause it to rotate forever. Okay, so for all three, for this is the initial loop configuration, and I've been asked to identify the north and the south poles of the magnet. And if you will check out your answers to activity 1, then you'll see that the north pole is here and the south pole is here. And the background magnetic field will be, I'll draw that in green here, points into the south pole of the magnet. So actually the background magnetic field points down into this magnet. So the permanent magnet down here, this is the magnet that's mounted to your, to the battery when your motor is spinning, has the magnetic field pointing into the south pole. Okay, and so I'll use the right-hand rule. I have a current of wire, current going out of the page in the presence of a magnetic field that points down. So current going out of the page and a magnetic field that points down, and I get that my force is to the right. And current going into the page and a magnetic field that points down toward the bottom of the page. So I'll do my right-hand rule looks like this. So my palm is going into the page, my fingers are pointing down toward the bottom of the page, and my thumb points to the left. Okay, and so this thing is gonna spin clockwise. And now I see the flaw in my design, so I'm gonna have to kind of make this up a little bit as we go. So this is going to spin this way, and a short time later, it's not going to go up, but it's going to be across like this. And this dot, as it spins this way, will go like that. This X will end up there. Okay, so I had to kind of cross out what is originally written on the homework assignment because I switched this to be a south pole from a north pole. So it's gonna rotate like that. And if you're good at thinking about north and south poles and how they, so this north pole will be attracted, and that's what also causes this to rotate in a clockwise way. So you might be able to do that without drawing the force arrows. I find the force arrows to be pretty helpful because now that I've figured out that a current out of the page will experience a force to the right, I know that it looks like that and like that. Right there. And so now there's no net force on this. And that's what it looks like. So just because there's no net force doesn't mean it's not going to keep rotating. So there's no net force, but right, something can keep spinning without a net force. So if you want to think about being like a bicycle wheel, right, you don't have to, if you get a bicycle wheel started spinning, and then you stop pushing on the bicycle wheel or accelerating the bicycle wheel by pedaling harder on it, right, you'll still continue to coast for a while, okay? So this is going to spin, and it's going to go through here. But now, if it keeps going, it's going to continue in the clockwise rotation that it's had, and a short time later, it'll be like this. So the dot will move from here down to there, and the X moves from here up to there. And now, again, I know that a force out of the page experiences a force this way, a current into the page experiences a force this way. And now, this is not a clockwise torque anymore, but a counterclockwise torque. Okay, so we don't want current to be on during this phase of the cycle. So I'm going to go ahead and cross this off and write no current. So hopefully this is, and this is why we had to strip only half of the wire and not the whole wire, because all that would happen with our loops if we stripped the whole of everything is that we would get a magnet that went like this and then like this and then like this and then like this and then like this, and it would never go around in a circle. It would just keep doing these half circles back and forth. So there's no current here. Okay, so we're gonna try to figure out how to make a motor go clockwise the whole time. So we're gonna say it gets here. The current can be on or off here. It doesn't matter. We want the current to be on, and then right when it gets to looking like this, we want the current to go off. And now we want it to be off here. And as this keeps rotating, I'm going to just fill these in like that. So there's no X's and there's no dots and there's no forces, because this thing is just rotating because it was already rotating. So now it has no net force on it, so it's just going to continue to spin. And as it continues to spin, this end that will be a dot is going to be end up oriented down here. So I need to change this one to look like that. And then it will go here. And I think we also want no current for any of these. Okay, so this would be a dot, and if it was a dot, it would experience the force to the right. And if it was a dot, an X, then this would experience the force to the left. And that, again, is the counterclockwise torque that we don't want. So we want the current to be off during this phase of the motion. And then next, as it continues here to our next thing, this would be the dot. So a dot experiences a force to the right. This would be an X. So an X experiences a force to the left. That still is a counterclockwise torque. So we want the current to be off in the loop there. So I won't draw my dots and my X's. And now, finally, this will rotate one more time so that it rotates like this. And now our loop is horizontal again. And again, I had to kind of cross off what is here for your homework because the homework problem is a little bit different. So, and now we can turn our dots and our X's back on. Now current is allowed to flow in the loop again. So right here, a dot has a force to the right, and an X has a force to the left. And this will not cause a torque, but remember, we're still rotating in our clockwise direction. So a short time later, the dot is going to move up this way. So it'll look like this. And now I'll have a dot up here and an X down here. And now I know that a dot experiences a force to the right and an X experiences a force to the left. And that is getting us back into this clockwise torque that we wanted before. So now the current is back on. Because this current being on in this cycle is causing this clockwise torque. And what happens next is this dot is going to move like that. So I'll get rid of this one right here and make it look like that. And we'll have a dot up here and an X down here. And now a dot has a force to the right, an X has a force to the left. And again, this is still that same clockwise torque. And then when we get back to the end, we are back where we started. Right, so this right here matches the very first thing up here at the top. And so we know, again, this experiences a force to the right, the X experiences the force to the left, and the current is back on. Okay, so the things that I have asked you to indicate for all three of these is that for each one of these, I want you to indicate the north pole of the electromagnet, like this. I want you to indicate the directions of the forces on the loop. So that's these two things right here, these two arrows. And indicate whether the loop will rotate clockwise, counterclockwise at all, or not at all. So this is clockwise torque. Down here is no torque. It continues spinning clockwise as before. Here's this one that is our next, right where we had the current turned off. And so I can again write that this is no torque. Continues clockwise from before. So it continues to rotate clockwise because it was before. I can also say ditto for that, right? There's no current, so there's no torque. There's no current, so there's no torque. And I can say the same thing for this one. There is current, I've allowed the current to come back on, but because these forces don't cause it to rotate, it's going to continue with its clockwise rotation. And now the current comes back on, so now I'll begin redoing my my north and my south poles. So this here is the north pole, and that here is the south pole. And I'm just getting these north and south poles because I have my results from activity 1-1 in front of me, and I'm able to just kind of get my piece of paper and rotate it around and figure out how it needs to be. And there's the north pole of this one and the south pole of this one, and the north pole of that one and the south pole of that one. All right, and I guess I should write that this is clockwise torque and clockwise torque and more clockwise torque. All right, so hopefully that helps step you through what I am expecting for this homework problem. It's exactly the same homework problem, only instead of it being instead of all these being S's, this is N's. So, and it should hopefully match up pretty well with the rest of the things we did in this lab as well.